Okay, so today we're going to start section 5, part A. We do have a quiz scheduled for next week. I believe it's on Wednesday. It is going to cover P4D, the factor completely, and P5A and B. So today, and then also what we're going to cover tomorrow. So let's first talk about domain. Now, we're not going to go too in depth with domain right now in this lesson. We will coming up later on in the next chapter. But the domain of an expression is really always going to be all real numbers. The only time it's not going to be all real numbers is if there's a variable in the denominator, because we never want the denominator of a fraction to be a 0. So whatever would make that denominator 0, we would exclude that from the domain. If there's a variable under the square root, we would also look to, we don't want a negative square root, so we would eliminate that. If there is a variable under a square root in the denominator, we would also eliminate that value. So we'll see more of this coming up. Right now, not in today's lesson, but just understand that always start out by assuming that the domain of an expression is all real numbers, except for these 3 scenarios, and then when we start to see them, we'll talk about them. So let's start right in simplifying our fractions. So the first one, probably like a 4th grade math problem, 6 over 30, and they want me to reduce this fraction or simplify it. Now, probably in 4th grade, they probably taught you to find a GCF, divide the numerator and the denominator by the GCF to simplify it. However, I know a lot of you would say, oh, I can divide them both by 2, and then you have to do it again by another number. But if you automatically would have divided by the GCF, which is 6, then you could go right to its simplified answer, which is 1/5. Now, what we're going to be doing with the polynomials is we're going to need to factor them. So another way that I could have simplified this fraction, and honestly, I don't need to do this when it's a simple fraction. If I were to take it and do the factor tree of it, do the prime factorization. So the prime factors of 6 would be 2 times 3, and then 30 are going to be 2 times 3 times 5. And then you would look for things to simplify. 2 divided by 2, and you're left with 1. And then the same thing with the 3's. And then notice you're left with just 1 over 5, which goes to your simplified answer. However, for fractions where it's just numbers, just reduce it however you need to. You don't need to factor those. However, for the polynomials, we will need to factor things. Now, one thing also to remember is when you have a rational expression or fraction, this fraction bar that's here, this is sort of like separating it. It's like a grouping symbol. So what this is doing is telling you that the top is grouped and the bottom. So it tells you the separation of the groups. So when I go to simplify this fraction, again, I'm looking, as long as there's no plus or minus signs here, I could just say, well, x divided by x is 1. So I could change this to a 1 and this to a 1. And now the only thing that's left is 3 over y. And my fraction is simplified. So just remember, anything divided by itself, whether it's 2 divided by 2, that simplifies to 1, or if it's a variable over itself, it simplifies to 1. When we go to simplify these things, technically they're canceling out, but what remains behind is a 1. Because again, when we did these x's and crossed them off, we were doing x divided by x, so what was left behind is 1. Let's look at the next one. Now, in order to get things to cancel, the denominator has to look the same as the numerator. And this is going to be especially important when we have plus and minus signs. So here, notice the top has the x plus y in grouping symbols, and so does the denominator. So because this looks identical, I can simplify, because again, anything divided by itself is 1, and then I'm just left with 2/5. Now, remember on the next one, remember that addition is commutative. So the order that I add two numbers doesn't matter. So technically on this next one, x plus y and y plus x are exactly the same thing. So this will also simplify and becomes ones, and then 1 times 2 is 2, and 5 times 1 is 5. Now, this next one is going to become very important to us. At first glance, you're going to say, wait a minute, Mrs. Corey, these do not look the same. However, I can make them look the same by factoring out a GCF. Now, when the sign of the two variables in the denominator are both opposite of what's in the top, so you see how this bottom one has a positive y, but the top is a negative y, and then here, this is a negative x, but the top is positive x. When both variables have opposite signs of the numerator, then what we can do to make them cancel is I can factor out a GCF out of my denominator. My GCF is going to be -1. So if I take y minus x and factor out a GCF of -1, then it becomes -y plus x, and I can even flip that around and then put the x first and then the y second, and now it looks like my top, looks like my numerator. So now what we'll do here is, this was the original problem. I'm going to factor out a -1 GCF out of the denominator, which now flips it around. And now I have something I can simplify. This will simplify. A 1 is left behind. I'm left with 1 over -1. 1 divided by -1, and this answer is -1. We will have to look for things like this when we're simplifying. So as soon as you see that denominator binomial looks very similar to the top, the signs are just opposite, know we can factor out a -1 GCF. Now, just like I told you about the binomial squareds, and sadly, people didn't listen to me on the test. There were people that when you have something like this, x plus 2 squared, you can't just square the x and square the 2 and tell me this answer is this. You had to write it 2 times and FOIL it. Many of you did not do that, and you missed out on the middle term. So when I tell you common mistakes, you should be listening to me, because people did this on the test and they got that question wrong. So when you are simplifying fractions, these are common mistakes. Remember, these are grouping symbols. So think of the fraction bar as splitting this into a top group and a bottom group. In order to get something to cancel, it needs to look identical. So in order to cancel that 3 plus x, there has to be a 3 plus x in the bottom. I cannot simplify the x and the x, because the x in the numerator is attached because it's got a plus sign. So this cannot be simplified any further. So if you have something being added or subtracted to an x, don't look to cancel it with a single x in the denominator if it's got a plus sign. Same thing here. You might think, but you just told me I could simplify something like this. The only time that's going to benefit you by pulling out a GCF of -1 is when both variables have opposite signs. So you see on this one, the x is the same sign. The y is the opposite. But factoring out a GCF of -1 isn't going to help me here. So this one can also not be simplified any further. Common mistakes are when you have something like 2 plus y and you've got a y down at the bottom. Do not do this. You cannot simplify things like that. Okay, right now this 2 plus y is attached. The only way I could have simplified a 2 plus y is if there were a 2 plus y in the bottom. Then it would simplify. So be very, very careful. Let's try some examples now. So easy 4th grade math here. Just simplify this fraction. I can divide them both by its GCF of 4, and this simplifies to 1/5. The next one. Notice there's no addition or subtraction signs. So I can actually simplify the y's here. If it had an addition or a subtraction sign, then I'd have to think twice about it. But this time I can simplify the y's, and then I'm just left with x over w. So again, if it were something like this, x plus y, and then w plus y, this cannot be simplified any further. So when it looks like this is already simplified. Do not cancel those y's when there's a plus or a minus, unless it looks exactly the same. We're going to see that with number 3. Remember, this is grouped together. Do not cancel the x and the x. You will get it wrong. The answer is not 1. The answer to this problem is it's already simplified. Nothing simplifies here. Do not cancel the x's. The only way that we could cancel an x is if we had an x plus 1. And let's say it had this. Then what I could do is I could cancel the x plus 1's. And remember, what gets left behind is a 1. So this simplified answer would be 1 over x. Good? Let's try the next one. Oh, here we go. This time we can simplify the x's because this x is being multiplied to this binomial. There's no addition or subtraction sign in between these two. So this will actually simplify, and I can cancel, and I'm left with x plus 1. Before we move on, let me just add a couple other things just so you can start to see some of these common things that you're going to see. So again, remember, anytime you have exactly the same thing on top of the same thing, this simplifies to 1. Because again, these would be grouped, and then you just simplify them. Anything divided by itself is 1. If you have an x minus 1 over an x plus 1, notice in order to factor GCF to be beneficial here, both of them had to have had opposite signs. See how only the 1's are opposites, the x's are not. So this would already be totally simplified. However, if I have x minus 1 and 1 minus x, now my signs are opposite, and I can factor out the GCF out of the bottom. So if I factor it out of the denominator, I'm ending up with negative 1 plus x. And if it helps you to see it flipped around so it looks the same, remember addition is commutative, so I can flip these. And it's negative 1 x minus 1 now in the bottom. And now you can see that it simplifies. And again, you're left with 1 over negative 1, which is negative 1. Also remember, if you have it written as 1 plus x or x plus 1, these are the same things. Addition is commutative, so this will simplify to a positive 1. Notice both numbers have exactly the same signs. Let's try some more examples. Now we're going to get a little bit more challenging here. We're going to be factoring trinomials and factoring out GCFs in order to simplify. First one's still simple. I'm going to go ahead and simplify the 3/6. That will simplify to 1/2. And then for the x's, we can do two things here. You could either say, well, I got 1x here. Let me take that away. And then 1 from this one. And then I'm just left with an x. The other way you could think of this as do what you did on the test. This is x to the first minus x to the 2 minus x squared gives you x to the -1. Remember, when you subtract the exponents, if it's negative, the final variable gets written in the denominator. So either way here. You could have also factored it. You could have said, well, the top is just 3x. The denominator is going to become 2 times 3, which is 6, and then x and x. And then you could look for things to simplify. Those become 1s, become a 1, become a 1, and then you're just left with 1/2x. So different ways to go about doing it. Number 6, here we go with our factoring. We need to factor this trinomial. We need to find the factors of -12 that when I combine them, I get +4 for my middle. So two numbers to multiply to give me -12, but the same two factors that when I add them give me +4. So again, you would start listing and you could say 1 and 12. Now notice to get a -12, my signs need to be different, and the bigger number is going to be the sign of the middle. So -1 times 12, -2 times 6, -3 times +4. I went too far. I didn't really need to do any more because here are my factors. Because -2 times +6 is -12, and -2 times +6 is +4. So the top, yes?
When you factor out GCF, does it stay in the fraction?
It stays in the fraction unless you need to simplify it. Absolutely. Okay, so here, this is going to factor into x plus 6, x minus 2. And just like he asked, I can factor a GCF out of the denominator. My GCF out of the denominator is going to be a 3. And then I'm left with x minus 2 after I divide. And again, now I'm looking for things to simplify. Only thing that I can simplify here is the x minus 2. Do not be tempted to simplify the 6 and the 3. That 6 is attached to the x. The only way I could cancel that 6 is if there were an identical x plus 6 in the denominator. So my final answer here is going to be x plus 6 over 3. And you are done. Again, this is attached. Let's try the next one. No factoring here. We can just simplify. So you could choose to factor the 18 if you wish, or you could just simplify 18 over 60. I can divide them both by 6. 18 divided by 6 is 3. 60 divided by 6 is 10. And then I can choose to subtract the exponents. So x squared minus x to the 5th gives me x to the -3. It's negative, so it gets written in the denominator. The other way you could do it, if you want, you could do the whole factor tree of 18, 2 times 3 times 3, and then x times x. 60 is 2 times 2 times 3 times 5, and then 5 little x's. And then look for things to cancel. This cancels, this cancels. I can do an x and an x. And now multiply everything that's left. Only thing left in the top is a 3. And in the bottom, 2 times 5 is left with the 3 x's that I didn't cancel. So either way on those. However, the binomials, the trinomials, they have to be factored if it can be factored. So let's try number 8. I need to factor both of these trinomials. These are easy trinomials because that a term in front of my x squared is a 1. So I'm only really just looking for the factors of negative 20 that are going to add to give me positive 8. And those factors in negative 20 are going to be positive 10 and negative 2. Because 10 times negative 2 is negative 20. But when I add 10 and negative 2, I get positive 8. Then I'm going to do the same thing for the denominator. Factors of 10, that give me 11. Don't forget about the obvious, the 1 times 10, because those are the two factors I need. So x plus 1, x plus 10. Again, it doesn't matter the order you're putting them in. If you want them lined up so it's easier to cancel, you could have put the x plus 10 first. But again, I'm looking for something to cancel top with a bottom. I don't cancel side to side. So the x plus 10s are gone. And then I'm just left with x minus 2 over x plus 1. Again, remember these are grouped. Do not cancel the x's and then divide that. You will get it wrong. In order to cancel the x minus 2, you would need another x minus 2 in the denominator. Okay. Again, remember also, always, 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 even if it's a trinomial, look for a GCF first. Well, the top's a binomial. So if it's a binomial, chances are it's a GCF, or maybe it's the difference of two squares. Or it could be the sum or difference of perfect cubes as well. So for the top, it's just a GCF. I'm going to divide it by 4. And then after I divide, I'm left with x plus 3. The bottom trinomial can be factored. I'm looking for the factors of negative 18 that when I combine them give me negative 3. Those factors of 18 are going to be negative 6 and positive 3. We will be doing factoring so much this year that this is going to become so automatic. You're going to look at those numbers and you're going to immediately know what those factors are. So now that I factored it, now I can go ahead and simplify. Only thing I can simplify are the x plus 3's. Do not attempt to simplify the 4 and the 6 because that 6 is attached to that x. So my final answer here is just 4 over x minus 6. Again, some of you are not listening right now, and on your test, you're going to simplify the 4 and the 6, and you're going to get it wrong. So only simplify when you've got something identical to match with it. Number 10, everybody good on 9? Here we go. Now, I can factor this the way it's written, and I'll go ahead and do that. If you prefer to rearrange it, you could, but I'm just going to factor it the way it was given to me. So factors of 12 are going to be 4 and 3, and it'll be a 4 minus x and a 3 plus x. Again, always you have the option of foiling it to make sure it goes back. Then the bottom one, this one's going to factor into, this one I can either guess and test, or I can do the grouping. 2 and 4 are small enough where I could probably guess and test and not have to do too many FOIL problems. But let me show you with the grouping, because again, that never fails. So if I go ahead and do the grouping here, I'm going to rewrite actually I'm going to multiply, and I'm looking for factors of 8x squared that when I add them give me negative 9. So two numbers to multiply to give me that, but who add to give me that. And again, don't forget about the obvious. Soon as that number is positive, that's a clue that your two factors are the same sign. And the same sign that they're going to have is the sign of the middle. So this is going to be a negative 1 and a negative 8. So then now what I'm going to do, and it's got x's here as well. So let's turn it into our factor by grouping, rewrite this term, come up with the two factors I just found, and it doesn't matter the order you put them in. So negative 1x, negative 8x, and then you're going to write the last term. Now you're going to make your groups. So I'll make a purple group And I'll make a black group. So GCF of purple is going to be x. 2x minus 1. GCF of the black group is going to be, and again, I want it to look the same, so I'm going to pull out a negative 4. And then I'm left with 2x minus 1. So the factor for that trinomial is x minus 4 and 2x minus 1. So x minus 4 and 2x minus 1. Now, first glance, yes?
I was going to ask, if you were to write it as 2x minus 4 times x minus 1, would that be the same thing?
No. So watch. Let's try to FOIL it and see if we go back. So you said to do 2x minus 4,
4, and then,
x minus 1?
yeah.
Okay, let's FOIL it and let's see if it goes back, because once we FOIL it, it needs to go back to this. So let's test it. So first, I get 2x squared. Outside gives me negative 2x. Inside gives me negative 4x. And then last gives me positive 4. Notice when I add the middle, I get negative 6x. And I wanted a negative 9. So when you do the guess and test, definitely do outer and inner to make sure you're getting that middle. So you see how foiling this just saved your answer? Okay, so if there's time, definitely do a quick foil, definitely do outer and inner. It will save your answer, especially with little details. Algebra 2 is filled with so many little details that if you're not careful, one little mistake and your whole problem's lost. All right, back to this. So, first glance, you're going to say, wait a minute, nothing cancels here. But look at the first two. Look at these guys right here. Notice how the 4 and the x are both opposite signs. So what I can do here is pull out a GCF out of either the top or the bottom. It doesn't matter. So let's say I want to factor a GCF out of this one. So if I pull out a negative 1, this ends up being negative 4 plus x. And then I can turn it around and do it x minus 4. And now it matches what's in the bottom. So let me rewrite what I just got. So factored out the GCF, it now turns into negative 1 times x minus 4. And then I'm going to rewrite the 3 plus x. And then the same denominator that was there. And now I have something I can cancel. So now the x minus 4's cancel. And now final answer here is negative, and you don't have to put the negative 1, 3 plus x over 2x minus 1. And again, nothing cancels because nothing is identical. If you want to distribute that negative sign to the top, you can, or you can leave it like that. Let's try the next one. Number 11. We got to factor the trinomial. So again, this is small enough where I'm going to guess and test because there's only 1 times 3 and 1 times 2 that are the factors of 3 and 2. So I'm going to do guess and test here. So I'm going to put a 3 here and an x here. And then for my factors of 2 and 1, this is where you're going to have to FOIL it real quick to decide, do you put the 2 here or the 1 here? And then by foiling it, you're going to see which one is the correct. So I'm going to put the 2 there and then the 1 here. Signs have to be different to get a negative 2. Now that I placed it in there, I got to quick double check it. So when I do outside, negative 3x. Inside, positive 2x. When I combine these, I do get the negative x that I wanted. So I put my factors in the right spot. Now, you could have also done factor by grouping on that. It works as well. All right, so that's the factored numerator. I can do the same thing on the denominator. I'm just looking for factors of 5 that when I combine them give me negative 4. So this tells me to get a positive 5. I'm going to do 5 times 1. So 1 and 5, and then minus x and plus x. Now, again, it's important where the plus sign goes and where the minus sign goes. So, again, FOIL it. So this gives me negative 5x. This gives me positive 1x. When I add them, I get the negative 4. If I would have put the subtraction here and the addition here, you would get it wrong. So you do have to FOIL it to make sure that you put the signs in the right spot. All right, so now I can see and look for things to cancel. Again, notice these guys right here, the ones on the end, see if I can get some highlight going. These two look very similar. So once you start recognizing these patterns, that the x and the 1 are opposite signs, immediately factor out the negative 1 out of one of them. And again, it doesn't matter. I know I did on the last problem out of the top. Let me do it out of the bottom this time. So I'm going to factor out a negative 1 out of this one here. So negative 1, and then it flips to negative 1 plus x. And again, you could flip it around so it looks like the top. So now the numerator stays the same. The denominator is now 5 plus x, the GCF, x minus 1. These will now cancel. And now I'm left with 3x plus 2 over 5 plus x, and then you can put the negative there in front. Let me go ahead and do number 12. Number 12, the only thing I can do is factor out a GCF of the numerator. So I'm going to factor out a positive 4, 3 minus x over x minus 3. Again, notice the numerator and the denominator. These two right here, they're both opposite signs, so I'm going to pull out the negative 1. So again, if you just want to cancel it now at this point, realizing that this would become a 1, you could change this to a negative 1, and now you're just going to multiply 4 times negative 1, and this answer is negative 4. Let's try 4 more. Now, number 13, the difference of two perfect squares. I am going to factor this with my pattern, x plus 5, just square root each of these. And then one gets a plus sign, one gets a minus. Nothing to do in the denominator. Now, if you want to go ahead and show that you factored out a GCF of negative 1, you could do that. And it would be negative 1, and then you flip the signs. So divide this, and it turns into negative 5 plus x. And then I'm just going to flip it around when I write it in here. So it matches perfectly. These will cancel, and then you're just left with x plus 5 over negative 1. You can go ahead and move that negative 1 to the top. So negative 1 times x plus 5. You can either just leave it like this, or you could distribute it in and give me your answer either way here. Number 14, this is just a GCF. So again, factor out a GCF out of the top. Now if you'd prefer, instead of factoring out a 4, I could pull out a negative 4. And then I'm left, actually a negative 4x. And then I'm left with negative 1 plus 2x. And then the denominator, pull out a 5. And then I'm left with 2x minus 1. And then if I just use my commutative property and flip around that numerator, and it's a minus, over the 5 times 2x minus 1, these cancel, and you're left with your final answer, negative 4x over 5. Two more, same thing. Let's just factor the trinomials and look for things to cancel. So for this one, I'm going to factor it the way it's written. So factors of 4, I can guess and test here. Factors of 4 are just going to be 4 and 1. I could try 2 and 2 as well. Again, if you're going to guess and test, definitely FOIL it to make sure it gives you the middle. So a quick check of my outer and inner. This gives me 4x. And then the inside gives me negative x. And when I combine them, I do get the 3 that's in the middle. So I did put my factors in the right spot as well as with the right signs. Now let's go ahead and factor the denominator. Again, you could do factor by grouping or guess and test. I'll just guess and test here, put a 2x here, an x here. Factors of 4 are either 1 and 4 or 2 and 2. I'm going to use 1 and 4 again. And then the signs have to be different. And now let's quick do a FOIL. Negative 8x. And then positive 1x. When I combine them, I get negative 7, which is what I wanted. So I did place everything appropriately. You could have also done factor by grouping on this. So now I need to look for things to cancel. Same scenario here again. I've got both of these that look backwards. So I'm just going to factor out a 1 and a negative 1. So when I divide this, this one is left as a negative 1, positive 1, and then I'm left with negative 1 plus x over 2x plus 1. And again, remember, these are grouped. Do not be tempted, again, to simplify the ones and then an x and an x. You cannot do that. In order to get anything to simplify here, I would need an identical copy of it, and I would need a 1 plus x in the bottom or a 2x plus 1 in the top. Last one, let's go ahead and factor the top. Difference of two squares, x plus 1, x minus 1. Bottom's going to involve a little bit more work. We're going to factor by grouping. So let me go ahead and write it down here. I'm going to make two groups, make a red group and a blue group. GCF of red is going to be x squared. GCF of the blue group is going to be 9. X plus 1. And then now put them together. The x plus 1, the thing that you have the double of, and then now the two GCFs you divide it by. Remember, there is no such thing as the sum of two squares, so I can't go any further. So let's go ahead and write these in the bottom. And then x squared plus 9. The only thing that we can simplify here are the x plus 1s, so you're just left with x minus 1 over x squared plus 9. Again, remember, the fraction bar is turning them into two separate groups. Do not be tempted to pull things out of a group and pull something out of a group from the bottom that you think you can simplify. Nothing else simplifies here, so we are finished. So that is it for the simplifying rational expressions.